So Learning Unit 11 really is sort of a continuation and a culmination of a lot of the skills that we learned in Learning Unit 8, 9, and 10. So we really think a little bit more deeply about covalent bonding and what we think about with bonds in molecules. So the first skill for this is what we call determining orbital hybridization. So again, we're going to build on a lot of the skills from previous learning units, and we'll see how those kind of come into play here. So let's talk about some of the things that we've learned already and how they're going to play into this latest learning unit. So in Learning Unit 10, we learned about shapes of molecules and how to determine shapes of molecules. And we learned about that because when we have electrons, either as bonds between atoms or as lone pairs on atoms, we need to give those electrons room. And that was that concept of VSEPR theory. We need to give those things room. And remember, those things were either electron groups as lone pairs or as bonds to other atoms. So we had that code, that A, X, and E that we needed to think about. So that led us to different electron group arrangements, depending on how many things we had surrounding a central atom. So now what we move on is understanding how those bonds are actually made. So not necessarily the lone pairs that are on atoms, but the bonds between atoms. How do those get formed? And we use another theory called valence bond theory to explain that. So when we're talking about the formation of covalent bonds, we already know that that's sharing of electrons. But really what happens on an atomic level is we have two atoms that come together and have their orbitals overlap, and the electrons that live in that orbital are now going to live between those atoms. And so we're going to be talking about concepts of mixing atomic orbitals, generating molecular orbitals, and so forth. So there's some rules that kind of we saw and maybe used in earlier learning units that are going to come to play here. So when we think about formation of these bonds, bonds again are going to form when we have an overlap of orbitals that contain electrons, but importantly, those electrons have to have opposite or paired spins. We sort of talked about that before when we had atomic orbital diagrams and we talked about how we filled electrons there. So that rule is going to be similar here. When we think about how strong a bond might be, the bonds are going to be strongest when there's a maximum amount of overlap between the orbitals used for that bond. So this is where kind of concepts that we learned about with shape are going to come into play. So we're going to have to think about shape and direction. When we think about atomic orbitals, and again, electrons in those atomic orbitals, right, we need to think about potentially making those of equal energy to generate these bonds. This will become more evident as we kind of go on to the next slide here, but this is this process of this skill that we call hybridization. We need to form hybridized atomic orbitals anytime we want to have bonds. And so we're going to talk about using hybrid orbitals. So when we think about these hybrid orbitals, and we'll get into some more details on the next slide here, there's some things that we can think about, general features of hybrid orbitals. So if we're talking about using and making some hybrid orbitals, however many hybrid orbitals we have, that has to equal the same number of atomic orbitals that we mixed. You're going to see an example on the next slide here that will hopefully help clarify that. The type of hybrid orbital that we make is going to be depending on what type of orbitals we mix. Again, we're going to see an example on the next slide that hopefully clarifies that. And then when we think about overlapping these orbitals in order to make bonds, the shape and the orientation is going to be such that we want to maximize that orbital overlap. Remembering that bonds are going to be the strongest and the most stable when we have this maximum amount of overlap. All right, so these are going to be some rules that play into all three skills from this learning unit. But the first skill is just on figuring out hybridization of central atoms. So here's how you do that. The first two steps actually apply to Learning Unit 10 skills that we already know about. We need to determine a correct Lewis structure. We did that in skill 10.1 from Unit 10. Then we need to determine the correct electron group arrangement. That is figuring out what the code is. That was in our second skill in Learning Unit 10, skill 10.2. So if you need a refresher on those, make sure that you are comfortable with those skills because we can't move on unless we have a correct Lewis structure and we've correctly identified the code for the electron group arrangement. All right, after this, it actually becomes pretty easy. I'm going to just give you a couple of generic examples here, and then there'll be a follow-up video here where you can, for extra credit, watch another video that actually will allow you to evaluate and see some examples of this in play. All right, so once you've determined what the code is, okay, you literally just need to count the number of X's and E's that you have. So in essence, it's whatever that M and the N value are. Okay, that's going to tell you the number of atomic orbitals that you're going to need to mix up to 6. And here's why it's 6. Remember the orbitals that we have. Think about doing those electron configurations. We always only had one s orbital, right? One s orbital that can hold 2 electrons. We could have 3 p orbitals that could hold up to 6 electrons. And then we also could have up to 5 d orbitals that could hold 10 electrons. But for this hybridization and this mixing, we're only going to consider 2 of those 5 d orbitals. So I want you to remember this series of letters, okay, 6 letters, S, then 3 p's, then 2 d's. The number of letters that we're going to use there corresponds to the number of X's and E's. We're going to do a couple of examples here so you can kind of see this in place. That will help us figure out how many orbitals we mix, and then once we determine which of these orbitals we mix, that's going to determine which ones are what we call hybridized. Those are the ones that we mix, and then there'll be ones that we don't mix that are going to be leftover, or we call those unhybridized. What we're going to do then is combine these letters together. Now we're going to use superscripts to indicate how many of each letter we mix together, and then whatever is left over is going to be an unhybridized orbital. All right, so I have 3 just kind of generic examples to go through here, and then there's going to be an extra credit video that I encourage you to watch that goes through several examples. All right, let's say that you figured out that the code for your central atom on your molecule is AX2E2. I have 2 atoms and 2 lone pairs then on that central atom. I have 4 A's and E's. Okay, what that means is that I am going to take 4 letters here. I'm going to take just an S and 3 P's. I'm going to leave these D's alone, not doing anything with them. But when I mix these together, I'm going to have 4 orbitals because I mixed 4 letters here. And I'm going to describe those orbitals as sp3 because that's what I mixed, an S and 3 p orbitals. Okay, there's nothing that's left that's unhybridized in this sense. We didn't use these d orbitals, so we don't really consider them. But we're going to have 4 sp3 orbitals, nothing that's left unhybridized. Okay, let's go through another example here. Let's say that your code was AX3. I have 3 X's and no E's, so I have 3 letters total, which means I'm going to be only mixing 3 letters total. So the red letters here represent what I'm mixing. So I'm going to get 3 because I mixed 3 letters, sp2 because I mixed an X, S, and then 2 P's, and then I'm going to have 1 unhybridized p orbital that's left. Right now, this code might not make a lot of sense in terms of what does this mean? We're going to get to that in our next skill. Right now, this skill is just identifying what the hybridization is on the central atom and what the hybrid orbitals are that we have from doing that mixing. One last example here. If we had a code that was AX5, okay, in this case, I would be mixing 5 letters here. So I would have 5 orbitals, 5 hybrid orbitals. They would be given the code sp3d, and I would have 1 unhybridized d orbital that was remaining. So I encourage you, watch this extra video for extra credit as we look through and I go through several examples of this sort of determining molecular or this hybridization, looking at it kind of in play here.